What makes data discrete and what makes data or variables continuous? Well, if we think about the random variable x as being cookies purchased, a person could purchase 1 cookie or 2. Theoretically, you can't really purchase 3.5 cookies or whatever, so this would be discrete. It's countable. If you're at a roller coaster, if you buy cookies before you go on the roller coaster, be careful because you might lose your cookies. But now here, what if I'm at the nursing home again 40 years from now and they're having chocolate chip cookies and I'm in my little scooter? Look at me, I'm on my way to get the chocolate chip cookies. So I might be traveling maybe, let's say, 1.5 miles per hour. What if though on another day they got oatmeal raisin cookies? Woohoo! Here I go. I love oatmeal raisin cookies. I'm going a whole lot faster on my scooter. I'm up to 3 miles per hour. But theoretically, on my scooter, I could be going 1.62 miles per hour, 1.77 miles per hour. There's infinitely many speeds that I can be traveling on my scooter. So this is a continuous variable. That's just discrete. Some other descriptors here, discrete variables. The data could be countable, the numbers are countable, or there's a consistent gap between the possible values, like you get 1 cookie or 2 cookies, you can't get 1.5 or 1.3. Continuous variables would be like all real numbers. There's all the fractions and decimals included, so there's no gaps between the possible values. It's almost like, and I've heard somebody make this analogy, discrete is kind of like peanuts, countable, chunky, there's gaps, whereas continuous would be more like peanut butter. All right, it's all together, smooth. There's infinitely many things. It's just one continuous, creamy, delicious thing. Okay, here we go. Integers. Integers, remember, none of those fractions or decimals in between count. So these integers would be discrete because there's gaps in between them. But if we were to all of a sudden say, let's talk about all real numbers, well, those include all real numbers include all the fractions and decimals, so we get to include all those numbers in between, and that smooths everything out. So all the real numbers, that would be continuous. There'd be no gaps whatsoever. Okay, think about this. Shoe sizes. You can have a 5.5, a 6, a 6.5. So there's gaps in between. Not that that's where you have to buy your shoes at the Gap, but anyway, so you'd have gaps in between. So shoe sizes would be officially discrete. But now, if we're asking somebody, how much sleep did you get last night? Even though they might say 5.5 or 6 or 6.5, isn't it true that though somebody said 6 hours, it might have really been 5.9117 hours? There's infinitely many numbers in between here also. So there's really no gaps, even though we'd report them with gaps. Technically, when it comes to time, it tends to be continuously distributed. Continuous. Okay. Finally, here's an example from the world of statistics. When you roll 2 dice and you add them up and get the sum, the only sums you can get are 2, 3, 4, 5, 6, 7, all the way up through 12. 7 occurs the most often, so we could show a distribution like this. This would be discrete. There's gaps in between. You can't roll 2 dice and get a total of 3.3. So this is a discrete bell shape. Now, if we start talking about heights of adult women in America, if we start looking at those heights, there's going to be a lot of heights in here. There's going to be a lot of women that are that tall, and then there's going to be less and less women as you go out to these heights right here. But if we start to put all these heights together, and all the heights of women as we go out here, they also tend to have a bell shape to them, but this would be continuous. Because technically a person could have any height between 64 and 65 inches, 64.33 inches tall or whatever. Both are bell-shaped, but this is discrete. This is a discrete variable, and that's continuous. So just a quick intro on what those things mean.